All right, so today we're going to really kind of delve into the whole idea of the unit circle. And this is kind of the central idea behind trig. This is kind of our main thing. Okay, so if you remember from geometry, we talk about the circumference of a circle. Okay, and circumference is the distance around a circle. Okay, and that's determined by the circumference equals 2 times pi times r. Okay, so when they're talking about the unit circle, unit in this case means the radius equals 1, or 1 unit. This is why it's the unit circle. Okay, so one trip all the way around the circle would be 2 pi r, or 2 pi times 1. So that's 2 pi. Okay, so one trip around the unit circle, the circumference equals 2 pi. All right, so pi is something that's known as radians. And for the most part, I have no use for radians. They're kind of a pain in the butt, to be honest. But nonetheless, the trig guys love them for some reason. So we're going to talk about how radians relate to degrees, because we kind of understand degrees. We kind of got a vibe for degrees, right? So for example, 2 pi is the distance around the circle. So that's one trip around the circle equals 2 pi. Okay? Now, from your experience, how many degrees is it in a circle? How many degrees are in a circle? All the way around the circle. How many degrees is there? Yeah, 360. Okay. So 360 degrees is a trip around the circle, and 2 pi radians is a trip around the circle. Okay, so both of these are even numbers, right? 360 is an even number, and 2 is an even number. So this is kind of a central idea to all this stuff as well. So pi equals 180 degrees. Kind of a big deal for this stuff. Okay, so we're going to pull this all together, talk about degrees versus radians. And like I said, they love the radians here for some reason. I'm not really sure quite why, but we're going to talk about that. Now, another thing for the unit circle, what you want to picture, and I should have pulled up a picture of something like this, but it's okay. So what you want to picture is you have a circle, right? It's at 0, 0, right, for the center. And the radius is 1. So this is 1 right here. Okay. So that's our setup. So as we said, one trip around the circle is going to be 2 pi. And that also equals 360 degrees. So half a trip around the circle is pi. And he equals 180 degrees. Okay. So what they like to do, they like to go back and forth between degrees and radians. I don't know what is going on there. Let's see if I can fix that up a little bit. All right. So this is 180. Close enough. All right. So we're going to go back and forth between these two. Now, one other important thing to know is if you pick a point on the circle, let's say right there, when we have rectangular coordinates, which is basically the XY stuff, right? That means, switch up colors here. If you want to get to this point on the circle and you want to go and use the grid here, you're going to go over this far in the X direction, right? And then up this far in the y direction. So this point right here will have some x value and some y value. Okay? Just a second. It's making me crazy, so I'm going to try to clean that up a little bit. So we'll have some x value and some y value. Okay. And then the radius is from the center to the edge of the circle, any place you want to go, right? So the radius in this case is always equal to 1 for the unit circle, right? You keep seeing it over and over, okay? So what you then have is this guy here is a right angle. So this whole thing, the whole bit about a circle, it's the Pythagorean theorem in disguise. Because if you square the short sides, so x squared, y squared, and add them together, you will get the long side or the hypotenuse squared. Okay? So that means x squared plus y squared equals 1. Okay? So Pythagorean theorem. Something else we've seen a lot of, something else we're kind of used to, right? Okay. So a couple other things to know in this particular situation. All right. So the x coordinate goes with cosine, and the y coordinate goes with sine. Okay? So when they say the sine of an angle, they're really asking you for the distance you've gone in the x direction. And then with cosine, they're asking you for the distance you've gone. And for the sine, then they're asking you the distance you've gone in the y direction. Okay? So this is where all this is headed. So any point I pick on this circle, anywhere on this circle, will have some x value and some y value, and x goes along with cosine, and y goes along with sine. Okay? So what we're doing is we're pulling a lot of stuff together you've done in the past and putting it all together. All right? So like circumference is 2 pi r. That's something from the past, right? Pythagorean theorem from the past, right? We've talked about degrees before, and the radians is kind of a new thing, but it still has to do with circumference, something we've done in the past, okay? And one of the new things we're talking about is just remember that the x-coordinate corresponds to cosine, and the y-coordinate corresponds to sine. The way to not get those confused is its alphabetical order. X comes before y, and c comes before s. So x goes with c, cosine, y goes with s, or sine. Okay? So all this is heading towards this unit circle thing. As you may have noticed, there's only 3 slides today, and the first one was just an intro slide. So a lot of information in a short space of time here. Okay. So there's certain angles that we talk about a whole lot in trigonometry. And those angles are multiples of 30, 60, 90, that kind of thing. And then also multiples of 45. So 45, 90, and then we'll continue on 190 or 135, 180, that kind of thing. We're going to get into all that as well. Okay. But the angles of measure they talk about on a unit circle are all either multiples of 30 or multiples of 45. All of them. These are the ones we're interested in. Now, obviously, there's other angles besides those, but these are the ones we use a lot. These are also the ones that we can get values for pretty easily, even without a calculator. Stuff in between, if they want to know the cosine of 22, yeah, we're reaching for the calculator. But we're going to talk about what it is when you get the cosine of 22. What does that mean? That kind of thing. All right, so that's where we're headed. And like I said, I know this is a lot of new information all at once. A lot of stuff that we've done in the past. You have to remember, pulling it together. Don't panic. You'll be seeing this a lot more. You don't have to get it all today, but let's see how much we can kind of get a hold of while we're thinking about it. Okay, so let's go ahead and look at two of these triangles that we use over and over in trig. And you've seen these guys before. Okay, so first of all, we have the 45, 45, 90. And then we have the 30, 60, 90. And when I found this particular thing, it cut off the bottom here, but I can put it back in. Give me just a second here. So notice that it says for the 30, 60, 90, the one on the right, it says that the hypotenuse is 2 units. The shortest side is 1 unit, so the long side is twice as long as the short side. And then this side here is going to be the square root of 3. Why it's a square root of 3, we'll come back to. Okay, but these ratios you need to know. Now at the 45, 45, 90, as you've probably discussed and forgotten in geometry, when you have equal angles, that means the side across from them or the side opposite them are equal sides. So since we have a 45 here and here, that means that our sides are the same, which in this case is 1 and 1. Okay, so picture this. Picture this is the center of a circle. So here's our center. This is our radius. And this is our point on the outside of the circle. So this is going to be a circle coming around this way, and this is going to be the center. Okay, so picture that. Now, for our particular case, we mentioned that the radius of a unit circle is going to be 1. And why this won't go away, I don't know. I'm trying to clean this up a little bit. There we go. Okay. So the radius is 1. Okay. Well, the radius of this guy is the square root of 2, right? So we'd like the radius to equal 1. So here's how we would do that. We would say, okay, if I take the square root of 2 and divide it by the square root of 2, I'm going to write up there just for the sake of space. Square root of 2 over the square root of 2, anything over itself is just 1. So that would make our ratio, instead of being the square root of 2, it would make our long side, or our hypotenuse, 1. Okay, so you know the deal in algebra. We just divided this guy by the square root of 2. That means both these guys have to be divided by the square root of 2. So if your hypotenuse is 1, your two short sides are both going to be 1 over the square root of 2. Okay, now, as you may or may not remember, the math guys for some reason have extreme prejudice against having square roots on the bottom of fractions. Why this is, no idea. But nonetheless, this is the rules we have to play with in this case. Okay? So they won't like it as 1 over the square root of 2. They're not going to like that. So what we have to do is what they call rationalize the denominator. And we did some of this stuff when we were talking about just simplifying radical expressions, which we haven't done for a while. But this is another thing that kind of comes into play. So as you can see, the trigonometry is pulling from a lot of different sources to get the information that we need to be functional with this stuff. Okay? So what we need to do in order to give them a format they like is we're going to multiply the top and the bottom by the square root of 2, because the square root of 2 over the square root of 2 is just a fancy version of 1. And if you multiply anything by 1, 10 times 1, it's still 10, right? So we're multiplying by a fancy version of 1, which means that our answer is still going to be the same, but it's going to look a little different, okay? But it's the same thing. An example I've used in the past is I used to have a slide that had a picture of Johnny Depp on the red carpet in a nice tux, you know. And then I had a picture of Johnny Depp dressed up as Captain Jack Sparrow, right? It's the same guy. It's still Johnny Depp either way, right? But one looks different than the other. That's exactly what we've got going on here. So what this guy's going to look like is you have 1 times the square root of 2, so that's going to be the square root of 2. And the bottom is the square root of 2 times the square root of 2, which is the square root of 4. But we know for a fact the square root of 4 is just regular 2. So these two guys are both going to be 2 over the square root of 2, or 2 divided by the square root of 2. Okay? Now, they like these answers. They call these exact answers. Okay? The reason they're exact is the square root of 2 is one of those numbers that's an irrational number. In other words, the decimal part doesn't ever end, and it doesn't repeat. Like if you take 1 divided by 3, you get 0.33333, and it just keeps going, right? Repeating decimals are okay. Decimals that end are okay, like 1/2 would be 1 divided by 2 is just 0.5. That's easy, right? Well, these guys don't do that. So if they want the exact answer, they want this. Anything else is considered an approximation. Okay? But I'm going to show you how to use your calculator to recognize these numbers. Okay? All right, so questions how I got that? Basically, all I did was I just divided everybody by the square root of 2. Okay, so that is our first triangle that we're concerned with. Our next triangle is a 30, 60, 90. So that is the guy on the right. Okay. Sorry about that. Hang on. There we go. Okay, so same deal. Now in this one, picture our hypotenuse is one end is like the center of a circle. The other end is sitting on the edge of the circle. So that makes the 2 here a radius, right? All right, so we said for a unit circle, the radius is 1. The radius of this guy is 2. One side will always be 90. Yes, that is absolutely correct, Charlie. So one angle is always going to be 90. Good. All right, so this guy, we have to do the same deal as the last one, except this one works out a little nicer. Okay. So this one, we don't want it to be 2, we'd like it to be 1, so we're just going to divide by 2, right? Because 2 divided by 2 is 1. So now we have a radius of 1, but then the other guys, we have to divide by 2. So instead of him being 1, he's going to be 1 over 2, which is just 1/2. And over here, instead of being the square root of 3, it's going to be the square root of 3 divided by 2. Okay? So the good news is, as far as this unit circle thing we're going to talk about here in a couple minutes, these are basically, let me highlight them here. These are the only numbers that you'll keep seeing other than 0 and 1. So there's 0, there's 1, then there's going to be the square root of 2 over 2. That's going to be a big deal. 1/2, going to be a big deal. And the square root of 3 over 2. Also going to be a big deal. All right, so let's just talk real quick about what the decimal approximation of these guys are. Because if you use your calculator and you get these decimal approximations, I want you to know that this is what it is. All right, so 1/2 is obvious. That's easy, right? 1/2 is 0.5. Okay? Square root of 2 over 2. Let's talk about him. So let's break out the calculator. So we got our calculator here. And we're going to go 2, square root it, and then divide by 2. So that's a 0.707. So the approximation on this guy is 0.707. Okay. So if you see that on your calculator, just know that that means the square root of 2 over 2. This will make life a lot easier. All right, so we'll do the same thing with the other guy. Calculator city again. So this one, clear it out. We take 3, we square root it. We get 1.73, blah, blah, blah. We divide that by 2, square root of 3 over 2 is 0.866. So 0.866. So if we do this on your calculator and we get this guy here, then you know that that's the square root of 3 over 2. Okay? So keep those in mind. There's a few other approximations we'll need, but not right now because we're not dealing with tangent just yet. Okay? So this is where we're at. So remember that the square root of 2 over 2 is about 0.707. The square root of 3 over 2 is about 0.866. Okay? Now remember what we said before when we were doing the SOHCAHTOA and we were doing the sines and the cosines and all that kind of stuff? Remember we always said that the answer for sine and cosine is never going to be above 1. And notice these guys aren't. One is 0.7, the other is about 0.87, 0.866, right? So again, they're less than 1. That's going to be the standard. Okay? Why are they throwing trig as? Quite frankly, Charlie, trig is actually one of the more useful forms of math there is. I mentioned maybe one day, I don't know if it was this class or maybe, because we talk about trig also in geometry this year. But another thing they use this for is when you see those like surveyors along the side of the road, and they've got those little devices they're looking through and all that kind of stuff. That is totally trig. That's pretty much all those guys use. There's all kinds of good uses for trigonometry. It's actually one of our better forms of math. So, but once we get into it, like I say, by using the calculator, we're going to show you how this stuff works. So, as a matter of fact, let's do that right now. So let's do the calculator here. See if we can make him a little smaller. Oops. A little more useful here. Let's see if we can do this. Oh yeah, there we go. That's good. Sweet. Okay. Well, I agree with your grandmother completely. And in Ohio, we had a class called Financial Algebra where they would teach you that kind of stuff. These days, I don't know how many people actually still have a checkbook. Most people don't write checks anymore, but the principles are still there. You still need to know the balance of your bank book. Okay? So, which is pretty much like doing the same thing, but you should be able to look at your bank statement and say, yeah, I bought that. That's what it cost me. This was the amount of money I had. I spent this much on that, so I should have this much money left. So yeah, totally agree. Okay, so for this one, let's talk about trig functions for a second. All right, so let's start with 45 degrees. Like I said, let's talk about degrees. All right, so 45 degrees, let's do the sine. So I hit sine of 45, 0.707. What did I tell you 0.707 is? Square root of 2 over 2. So the sine of 45 degrees is the square root of 2 over 2. This is heading for the unit circle again. Okay? Now, it turns out, remember we said with the 45, 45, 90, the two sides are the same. So the sine is the same as the cosine. So that was sine. So let's do 45 of cosine. We're expecting to get 0.707 again. And we do. Okay? So the sine of 45 and the cosine of 45 both equal 0.707, which is the square root of 2 over 2. All right, so let's talk about the 30s and the 60s here. So 30. Let's take the sine of that guy. So we go sine. That's 0.5, right? 0.5 is 1/2, right there. Right next to the calculator. Yeah? All right, so then let's do cosine of 30. So here's 30. Let's do the cosine. So we go here, we go cosine, 0.866. So then the cosine of 30 is 0.866, and the cosine of, or excuse me, and the sine of 30 is going to be 0.5 or 1/2. So this is just so if you put it in your calculator, you recognize what those mean and you know what the answer is. So 0.866 is the square root of 3 over 2. Okay. Square root of 2 over 2 is 0.707. That's why I mentioned this. Most teachers don't do this. They just say, you have to know it. Come on, man. As you're going to see in a few minutes here, there's a lot of stuff you need to know. And we probably won't get all this finished today, but we'll get started on it. Okay? Cool. All right, so that's where we're at. So now let's move on to this unit circle thing. Okay? So everything we talked about is all going to come into the unit circle. A lot of things happening here. Okay? But we're going to try to lay them out and explain what they are and what they mean. So today, let's see if we can maybe just talk about the first quadrant. Now, the first quadrant on a graph, when you have a graph, is this bit. The first quadrant's over here, right? So if we put a circle on this guy, if we start our circle at 0, and we go to the first quadrant, that's going to be 90, because remember, 360 is all the way around a circle, right? So at 90 degrees, we are 1/4 of the way around the circle, or quadrant 1. So quadrant 1 happens between 0 and 90. Okay, so that's where we're headed with this. All right, get ready for this one. Oh man, what is going on here, right? All right, so probably should have just done the first quadrant on this. It's going to be hard to put all this stuff into place, but we're going to try. All right, so notice that on the inside of the circle, we have a bunch of little tiny circles. Those are degree measures, okay? So this is where we always start. We always start here at the beginning of the positive x-axis, and we go this direction, okay? So as we go that direction, our degree measures are going to get bigger, okay? So let's start with, see if I can make this a little thinner but still be able to see it. Let's try that. All right, so if we start right on the line here, you can also picture this as being a Ferris wheel, but the platform where you get on the Ferris wheel is right here. So we get on the Ferris wheel, this is going to be considered ground 0, okay? This, again, is 0, 0 in the middle of your XY graph. That's a 0, 0. So the main shaft of the Ferris wheel that this thing rotates around is going to be considered 0, 0. And the platform is right here at x equals, or actually y equals 0. You haven't gone up or down. Okay? And that's where we get on the Ferris wheel. So we get on the Ferris wheel. Thing hasn't moved. All right? So we're at 0 degrees. Okay? And we're not going to talk about the radians just yet today. We're going to just work with the degrees. We'll get to the radians. I'll make a bigger version of this that will help us to where we're going. Okay, so if we're at 0 degrees, well, where does that start? Well, we come all the way over here to 1. So we go over in the x direction 1, right? And we haven't gone up or down at all, so the y direction at this point is 0, because we're sitting at the platform. Okay? Now, when we get up here to 90 degrees, right, so it's up here. So 90 degrees is right here. At that point, we're at our highest point, right? So the highest point we get to at this point, and remember the height up and down is the second term, this is going to be 1. So that's as high as we're going to go on this thing. All right? And at this point for the y value, we haven't gone left, we haven't gone right, we've just gone straight up, right? So that means this is 0. So at 0 degrees on our xy graph, we're at 1, 0, and at 90 degrees, we're at 0, 1. Okay? All right, so we have some degree measures in between. All right, so halfway in between, so we're halfway between the platform and our highest point, halfway between 90 and 0, right, 0 and 90, is 45 degrees. That's halfway there. That's this guy. So he's 45 degrees. Okay, so notice that we have some points on our circle. We've already talked about some of these points, right? So the first point is your x coordinate, right? Second point is your y coordinate. Makes sense. That's what an ordered pair always looks like, right? So we're at 45 degrees. What's our x and y coordinates? Let's go back to this guy. We're at 45 degrees. What's our x and y coordinates? How about square root of 2 over 2 in both cases? All right, so let's go back. So that's telling us this is going to be the square root of 2 over 2. And this is also going to be the square root of 2 over 2. All right. I'm definitely going to have to make a bigger version of this. Matter of fact, I should try to do that right now. Yeah, we don't have time. We're almost out of time. All right, we're going to stick with this for right now. All right, so then the other versions, like I said, we'll be doing this next time too. I'm just trying to give you the intro to all this. So remember I said that when we're talking about the unit circle, there's going to be multiples of 45 and multiples of 30. So that makes me think that this guy is going to be 30. Okay. All right, so 30 means we're going to go so far in the x direction, so far in the y direction. And remember early on I said this x is cosine and the y is sine. Okay? So let's talk about 30 degrees. What is our coordinates here? Well, in this direction, we've gone out a lot further than we have in this direction, right? So all of a sudden, if I do that, that's a 90-degree angle right here. This guy's 30. We know they have to add up to 180, so that makes this guy 60. So this guy up here is 60. And this is the angle we're talking about right now, is this 30. Ladies and gentlemen, a 30, 60, 90 triangle. So on the 30, 60, 90, in the x direction, we go square root of 3 over 2. In the y direction, we go 1/2. Oops. Where did I go? Hang on. There we go. So in this guy, like I said, we don't have enough room here. That's why I'm going to make this bigger. This guy here is going to be the square root of 3 over 2. And then the value next to him is just going to be 1/2. All right, so then let's change colors here real quick. So the next guy we're going to talk about is going to be this one. This is going to be 60 degrees from here to here. And notice that here it's just going straight up to here. So again, this piece is shorter than this piece. But what we've done is we've flipped this triangle on its side. So if you're talking 60 degrees, then what you do is you switch your x and your y values. So notice here in the case of the 30 degrees, we had the square root of 3 over 2, and we had 1/2. This guy is going to be the same values switched. All right, so then what that's going to be is this guy here. The first one is going to be 1/2, and the second one is going to be the square root of 3 over 2. Now here's the good news. Once we have this first quadrant done, we'll go over this stuff again next time. Okay, and like I say, I'll get a thing that's just this. That's just this first quadrant here. It'll just be, whoops, it'll just be this piece here. Why does it keep doing that? It'll just be this piece here. Okay, so I'll have a blow up of that, and we'll be able to use that a little better. Once you can do this first quadrant, the other quadrants are easy. So it's not like we have to figure this out 4 times in a row. You figure it out from 0 to 90. All you have to do then is notice here is these are both positives, right? Everybody's positive here. Then over here, your x values are negative, y values are still positive. Down here, everybody's negative. And over here, our x values are positive, but our y's are minus. Okay? So it'll be the same numbers. I know this is a mess right now. We'll get this better, I promise. It's just going to be the same numbers with different signs. And you will have the entire unit circle down. Okay? So like I said, don't be scared. We'll get this stuff down. It's not going to be that bad. I just need something a little better that I can work with here. But I had to throw this together pretty quickly today. My apologies. All right, so again, don't panic. We'll go over this stuff some more. We'll get you there. All right. And on that happy note, we're going to stop there for today. So I want to thank you all for showing up. And we'll talk about this unit circle thing again next time.